Hello, in this video we're going to deal with the Nobel Prize in Physiology or Medicine for 1913, awarded to Charles Richet for his work on anaphylaxis. And we deal here with his Nobel Prize lecture. First you see a stamp commemorating his discovery. Anaphylaxis is a simple name of the lecture. It is summarized by me. Here you see a diagram which explains more about allergy, which is related, of course, to anaphylaxis. This is for later development. If you want to study it, pause the video. And here's another one. Allergic inflammation, of course, related to anaphylaxis. As said, if you want to study it, you better pause the video. It's a later development, which started with the work, of course, of the Nobel Prize laureate. This is not a complete lecture, it's summarized by me. This means, of course, as always, that sometimes big steps are taken and argumentation is skipped. It is not a replacement of reading the original text, of course. Well, what's the goal here is to set out the findings that give anaphylaxis a leading place in general pathology. This is the words of Richet, of course. The word anaphylaxis means a state of organism in which is rendered hypersensitive instead of being protected. For instance, when one has received a poison, not too much, so after a few days all appears to be normal. What if a second dose is given? There are three possibilities. The same phenomenon as the third time repeats itself, the substance becomes less sensitive, a higher dosage is needed for the same reaction. These two reactions are long since known. Then there's anaphylaxis, the third possibility. The Coelenterra, called Physalia, is Portuguese galley, contains a strong poison on its tentacles. Touching a feeler with poison is painful due to the penetration of the liquid poison. Prince Albert of Monaco advised me to study this Physalia poison. When Richet and Porter, I found it dissolves in glycerol and this solution is also poisonous. Back in France, they compared the tentacles of the Physalia to those of actinia and anemone, which are easily obtained. Actinia tentacles treated with glycerol give off their poison. Sorry. The extract is toxic. With Porter, I set out to find how toxic it was. The lethal dose of this slow-working poison is 0.1 liquid per kilo, live weight of the subject. Unexpected phenomena. A dog injected with the smallest dose, 0.005 liquid per kilogram, showed serious symptoms and in the end died. It was found out that 3 to 4 weeks of incubation must elapse for such an epileptic result after the first injection with the poison. In 1902, Artus, Rosano and Anderson got similar results. An anaphylactic state can be produced by blood of an animal in another manner. The incubation period depends on the poison used, not on the animal. It's harder to say when an anaphylactic period is past. It can take years. Sometimes returns to normal is not even possible. Anaphylactic symptoms vary to a great extent. This is mainly due to the animal and not to the poison. The lightest form is prurine or itching, sneezing, head shaking, head scratching, rolling to the ground. The next stage, more violent itching, rapid breathing, lowered arterial pressure, faster heartbeat, vomiting, blood diarrhea, rectal tenesmus, and the third degree, depression of the nervous system, complete loss of strength, drunken reeling, dilated pupils, haggard eyes, falling to the ground, urinating and defecating, unconsciousness, giving no reaction, agonizing breathing, faint heartbeat, very low blood pressure. This is anaphylactic shock. Fourth degree, increasing all symptoms and death. Whether or not an animal survives an anaphylactic shock depends also on the species of the animal. Anaphylaxis also takes place in humans and can cause death. Pickett and Sheik have studied what they call serum sickness. This is an anaphylactic phenomenon that happens when children are injected with diphtheria serum, most often after a second injection. The symptoms observed in such cases are very close to the ones described above. It is as if the poison reacts upon the nervous system, especially the motor nerves or the trophic nerves of the skin. It is now opportune to examine the substances apt to develop this anaphylactic state. There are two groups, colloids and crystalloids. Crystallizable salts and alkaloids do not produce anaphylaxis. All animals and vegetables proteins do. The reaction is always stronger when the two injections contain the same substance, there is thus specificity. Anaphylaxis has been used in forensic medicine, and it is used to check whether or not blood on a crime scene is human blood. Two animals are injected, one with dog and one with uroserum. A month later, the unknown blood is injected. The anaphylactic reaction appears if it is human blood. Back to specificity, difficult word, it must not be overstated. For instance, guinea pigs, also react to serum of cows and goats. It has been shown, for instance, that anaphylactic dogs are more sensitive than normal dogs to many substances. Biological chemistry will no doubt unravel why, for instance, two related substances can work as a preparatory and enlacing substance. In 1907, I showed the very nature of the anaphylactic process. The serum of an anaphylactic dog includes an anaphylactic state in a normal dog. The serum of this contains the toxin and can cause death. Actinocongestion does, if that is the serum, well, normally is harmless. Gay, Savard, and others showed that passive anaphylaxis exists. Another step, anaphylaxis in vitro, allowed me to synthesize the poison. This works best with crepitin. It is harmless when injected solved in water. It is very offensive when injected in the serum from an anaphylactic dog. It becomes a poison able to kill fast. An experiment by Bernard long ago showed the same situation. Two substances, both being harmless, can be poisonous together. Amygdalin and emulsin together cause the production of hydrocyanic acid. In general, I call the two substances the toxigenic and the antigen. The one substance is activated by the other. Besserik, Da, and Freiberger came to similar conclusions. I was able to indicate the relationship between leukocytosis and anaphylaxis. I did this experiment with Lacibière. The number of leukocytes in anaphylized dogs, which have returned to normal, is double that of normal dogs, 200, respectively 100 per 100th of a cubic millimeter. An initial injection that makes the body anaphylactic induces leukocytosis, the only symptom that can be observed. A similar phenomenon is observed with dogs that are chloroformed. Leukocytosis takes place after a third or fourth doses. There is no real anaphylaxis. Probably the chloroform works on the hypothetical cells and causes the breakup of the proteins. There seems also to be an indirect anaphylaxis, widening the scope of the action. There is also a possible relationship between anaphylaxis and tuberculin reactions. In fact, a first reinfection of tuberculin does not make normal animals sensitive to a second infection. The blood of tuberculosis animals does not induce passive anaphylaxis. Lastly, the anaphylactic reaction is on the whole one of hypothermia, with the tuberculin injection on tuberculosis subjects always cause hypothermia. This may not be fundamental objections. Anaphylactic methods of diagnosis can be used in general. A serum may be injected to a patient or an animal to see if there is a reaction to the toxin. Maybe it can also be used to diagnose cancer. Unfortunately, experiments have until now been unsuccessful. It also seems there is no such thing as homogeneous anaphylaxis. Blood of one species injected to an animal of the same species is harmless. Now, anaphylaxis, which comes after injection by way of the digestive system. Rousseau and Anderson investigated that in 1906. The results have not been constant or uniform. I tried a different approach in what circumstance food can cause leukocytosis. With dogs, cooked meat does not, raw meat does, it results in leukocytosis. Probably because in cooked meat the proteins are non-soluble, but not in raw meat. The soluble proteins act as an antigen injection, setting off leukocytosis, and an anaphylactic reaction can occur. With the substance crepitin, I caused a clear instance of this elementary anaphylaxis. There are three methods to induce this, called elementary ingestion A and parental injection B. 1. Preparatory releasing, 2. A then P, 3. P then A. In all three cases, anaphylaxis takes place for crepitin. Wells and Osborne in 1911 studied the designing and immunizing action of physical proteins. Conclusions: through the digestive mucous membranes pass tiny amounts of chorions that can cause an anaphylactic state, but more often result in immunity. It may be so that many cases of dyspepsia are light attacks of anaphylaxis. Strict diet of some proteins may result in immunity. The symptoms of many sensitivities or allergies to certain foodstuffs are analogous to anaphylaxis. Now coming to a conclusion. Anaphylaxis and immunization create humoral differentiation between individuals. Many substances are anaphylactizing and many others can immunize. Each organ will accumulate immunities or anaphylaxis that pertain to it. Every individual has a humoral personality with stored memories. Just like a moral personality, he does seem to have a humoral personality. This is a new idea. The physiology of the species is not enough. We also have a personal physiology. How does anaphylaxis fit into the protection of organisms? It seems absurd that an organic disposition should make a being more susceptible to poisons. Anaphylaxis, perhaps a sorry matter for the individual, is necessary to the species, often to the detriment of the individual. Dangerous proteins can cause death or immunization. This is a defense mechanism against the penetration of heterogeneous substances. Yeah, it's a bit drastic to have death as a better situation than the penetration of dangerous proteins, but on a level of the species, it can work, of course. For the individual, of course, immunization is better. That's clear. Well, this is a summary, of course, as always. That means sometimes big steps have been taken. If you want to follow the complete line of thought and all the argumentation, you have to read the complete lecture, of course, which you can find here. This link is also in the description of the video. Here again, you see two illustrations from later work on allergy and anaphylaxis coming from the Wikipedia Commons department. Here's another one. You can see different types of hypersensitivity. This is all, of course, later derived from the work described in this lecture here. Well, this is it for the moment. Next week we will go into the Nobel Prize of Physiology or Medicine for the year 1914. For now, thanks for watching and maybe until another time.